we talked about naming ionic compounds, and now we'll talk about molecular compounds. Unlike ionic compounds, we can't figure out the formulas based on the charges that the elements have when they form ions because there are no ions. And you can have the same two elements that will combine in multiple different ways. So the example here is there are 6 unique molecular compounds between nitrogen and oxygen. So the system of naming for ionic compounds doesn't work here. How do we identify molecular compounds? In Chem 1A, molecular compounds are composed of 2 nonmetals. We'll see some things that have 3 nonmetals. Those are going to not end up being molecular compounds, at least not named that way. So for molecular compounds, we use numerical prefixes, and those are the same as the hydrate prefixes. And we put the prefix in front of the element's name to tell how many there are. So you look at the formula, and it's the subscript after that tells you how many. In the name, it's the prefix before. Which element goes first? It's the more metal-like element. So in ionic compounds, it's always metal, nonmetal. Here, we have 2 nonmetals, but we're going to pick the one that's most like a metal. Well, how do you figure that out? Well, generally, it's going to be whichever element is to the left on the periodic table. So the smallest group number. And if you're in the same group, it'll be the biggest one. Needing to know that doesn't come up very often, but sometimes people wonder, why is it this way and not the other way? So the names here follow this pattern. We use a prefix attached to the name of the first element, and then there's a space, and a prefix attached to the name of the second element. But like with monatomic ions, the second element changes the ending of its name to "ide." It's not an ion, but it has that alteration when it becomes part of a compound. If the first element is only 1, we frequently leave out mono. So if you observe that, and you're like, wait, there's only 1, it should be mono. The first one, it's usually left off. I got no real explanation for that one. If we look at NO2, so the formula tells us there's one nitrogen and 2 oxygens. The first element is nitrogen. We're not going to say mononitrogen. This is nitrogen, and 2 oxygens is dioxide. And then this is something. Water and ammonia always use their common names. So H2O would be dihydrogen monoxide, and ammonia would be nitrogen trihydride. And I will know what they are if you call them that, but everybody calls them water and ammonia because they're so common. Any questions? Name this compound, N2O5. So the first one, there is a penta in here.
Oh, wait, sorry. Dinitrogen.
Yeah, dinitrogen. And then the penta. And what do we do with oxygen's name? Oxide. Now, this double vowel business that we sometimes end up with, many times the vowel at the end of the prefix is dropped, and so you might see that as pentoxide or pentaoxide. I don't care. I'm not going to mark you wrong. On an exam, this will probably be a multiple choice question, and I will not try to trick you with that, okay? But just if you're wondering, where did that letter go? That's what happened. and then writing the formula from the name. So this says phosphorus, and it doesn't have any prefix. So how many of them are there?
One.
Just one. And then bromide is 3. Br3. Okay? This is the system of naming that students want to apply to everything because it makes more sense than the other ones, right? But you can only use it for molecular compounds. If you use it for ionic compounds, it's wrong. If you use it for acids, it's wrong. So if your compound starts with a metal, don't use these prefixes, okay? So we don't really need to talk about those guys so much. Acids. Acids are molecular compounds, but they're special because they release hydrogen ions when dissolved in water. And in terms of naming, it's really only named as an acid if it is dissolved in water. And this is how we indicate that something is dissolved in water. AQ stands for aqueous. So if we have HCl AQ, that means that HCl is dissolved in water and it should be named as an acid. HCl is actually a molecular compound. It's 2 nonmetals, right? How would we name it with that system? Hydrogen monochloride. Okay, so that would be this because that in its pure form, it's a gas. This is also something I'm not going to try to trick you with. So acids have hydrogen in them. That makes sense because when it dissolves in water, it releases hydrogen ions. If there's no hydrogens in the formula, how does it make hydrogen ions, right? So all the acids are going to start with H. So if it starts with an H, I want you to name it as an acid. Some of them, like HCl, can also be named as molecular compounds, but we're going to name them as acids. Okay? Any questions about that? Acids have some properties in common. They taste sour. Sour Patch Kids has acid on the outside. It's not the acid that people sell in the street, but it is an acid, right? Acids taste sour. Many metals dissolve in acids, but not all. And then their formulas generally start with an H. And in Chem 1A, they always start with an H. So we can break acids into 2 different groups. Oxy acids contain hydrogen and an oxyanion. In other words, they have oxygen in them. Oxy acid. Starts with an H, has an O in it somewhere. So those are the oxy acids. Anything else that starts with an H is in this group, which the book calls binary acids. And that name works for most of them. Those are going to be hydrogen and a nonmetal. So for those binary acids, we're going to use the prefix hydro to kind of stand in for hydrogen at the beginning of the formula. And then we're going to take the nonmetal, take its name and change the ending to ic, and then put the word acid on the end. So if we have HCl, this is two elements, hydrogen and a nonmetal. So for the hydrogen, we just write hydro. And for chlorine, we change its ending, there's no space here, to ic, so hydrochloric acid. All of the acids have the word acid at the end, so they're really easy to recognize from their names. So what would this guy be? HF. hydrofluoric acid. I'd like to point out that there is no flour in fluorine. It's gluten-free. So try to spell that correctly. What's the formula for hydrosulfuric acid? Well, what are the elements in it? Hydrogen and sulfur. Well, is it just 1-to-1?
H2.
Yeah, it's going to be H2S. So why? It's a molecular compound, but when you put it in water, it turns into ions. Okay? It makes hydrogen ions. And what kind of an ion does sulfur make? -2. So in its pure form, it's not ions, it's covalently bonded, it's a molecular compound, but you put it in water and it forms ions. So that tells us how many hydrogens we need. We need 2 of them so that this can be neutral. Okay? Any questions about that? The oxy acids have oxygen in them, and their names are based on the name of the oxy anion. So if we look at HNO3, if we cover up the H, we should be able to recognize that's an oxy anion, right? What is it called? Nitrate. That's the nitrate ion. When you put this acid into water, it forms hydrogen ions and nitrate ions. So the name is going to be based on the name of the anion. So nitrate, we take the ate ending and change it to ic and put on the word acid. And if it was nitrite, then we'd change it to us. So this is nitric acid. And there's no hydro at the beginning. So we need to associate ate and ic, ite and us. It's another one of those pairs of things that you have to get lined up correctly. There's a couple of different ways. There are sentences. Mnemonics. Maybe not technically a mnemonic. I distract myself. The white mouse ate icky cheese. So how does that help you? Well, there's the ite and there's the us. Here's the ate and there's the ick. Or, some people it's good enough to say I ate it and I said ick. Maybe that's good enough for you. And another one is Rick ate him before he could bite us. It's just, you could make some weird cartoon out of that. Rick ate him, before he could bite us.
Sounds like a zombie movie.
Right? And, you're welcome to make up your own, too. So there we've got the ite and the us. The O's missing, but good enough. Ick and ate. Okay? You just have to remember them. So let's write this, the name for this guy. HNO2. Cover up the H, and what oxyanion do we have? Nitrite. So this is the nitrite ion. So this dissolves in water and makes NO2 minus and H plus. And so we're going to change that ite ending, bite us, to us. So it's nitrous acid. Once you see it, it's like, oh, well, that makes sense. but you need to get there. It's like a lot of things in chemistry. It's kind of like learning to play a new game. I tell you the rules and they don't make any sense, and then we practice on the worksheets or in lab, and you make mistakes and you get corrected and you figure it out. Okay? And so there's nomenclature questions on the worksheet we're doing in lab today, and I want you to work on those and ask me if they're right, and then we can make it clear in your mind how this all works. So that's writing the name. What about writing the formula? Well, perchloric acid, perchloric, that name comes from which ion? We change ic and 8 go together. So this has the perchlorate ion in it. So perchlorate ion, HClO4, -1, and hydrogen. We look at the charge on this oxy anion, and that tells us how many hydrogen ions are necessary. So this would be HClO4. Any questions? That example kind of gets ahead, but so if this is how you write formulas, when the name ends in acid, you know it's an acid. I don't think anybody has a problem with that. That means the formula starts with H. You write the formula like it was ionic, even though it's molecular, because when the acid is dissolved in water, it does form ions. If you have the hydro prefix at the beginning, that means you have hydrogen and another element. You don't need any prefix. There's no prefix for the oxy acids, but they will just no prefix. And so then here's the ic and the 8, the us and the ite. So here's some extra examples. Write formulas for the following. Hydrocyanic acid. Is this an oxy acid? No. This is why I don't like the name binary acid, because how many elements are in this? Well, we have to write the formula first. Never mind. There's 3. So hydrogen, and then you can look for a long time for cyan anything on the periodic table. This is cyanide, which is Cn minus, one of those polyatomic ions. So cyanide and hydrogen, we're going to get HCN aqueous. Now, it follows the rules that the other binary acids do, and it's not an oxy acid. There's no oxygen in it, right? But it's not really a binary acid. Phosphoric acid. That's an oxy acid because it doesn't start with hydro, and we change ic to 8. So this is from phosphate. What's the formula for phosphate? PO4 3 minus. And this is why we memorize them, so we don't have to go look up everything all the time. How many hydrogens will we need with this phosphate to have a neutral molecule? 3. There's this 3 minus charge here, so we need 3 of these guys, and so the formula is H3PO4 aqueous. How about this one, hypochlorous acid? We want to say it's binary because it starts with high, but it's not hydro, it's hypo. And I put that one in there because it's a little bit tricky. So hypochlorous, us comes from ite, so we need the hypochlorite ion. So this is going to have hydrogen, and so chlorate had 3 oxygens. Chlorite was 2, and below that, hypochlorous is only 1 oxygen. and it has a -1 charge, and so the formula is HClO. Any questions? Yes?
Every time we write down an acid, do you want us to include aqueous?
Some people would say yes, but I personally don't care. Yeah. I'm just trying to be consistent, so, good question.